Welcome to clickmyproject.com. Let we discuss about the process automatic road crack detection and characterization. Let me see the abstract of the process. The cracks in the road can be detected with the help of road images. A supervised model is developed for the identification of the cracks in the road images with the help of extraction of the features from the images. The features were extracted and normalized and based on the resulting feature values, the detected regions were categorized into crack or non-crack. Based on the extracted features, the image is labeled as crack or non-crack. In the testing phase, the features were extracted from the images and cracks in the images were identified. The cracks were then further classified into different types by comparing the extracted feature values with specific threshold proposed. The performances of the processes is finally measured. The cracks in the road may lead to accidents and other damages. In order to identify the cracks in the road images can be used to identify and classify the crack. The cracks in the images were in different intensities compared to the other regions. In order to identify the particular intensity in the image, the segmentation processes can be employed. The segmentation processes based on supervised learning is proposed in this process. Crack detection in pavements and objects has been a constant field of research in management of the pavements in all big real estates. Conventionally, humans were engaged to detect cracks in the pavements and they were used to present the report sheets based on the assessment. But in this process, we propose an automated system which overcomes the time consuming and costlier crack detection processes employed. The researchers were trying for more alternate method that would detect cracks and minimizing the human involvement and the timely detection of the crack with more precisely. This method is proposed for this processes only and the overall performances of the processes were measured. Let me see the flow of the process. First, the training images were labeled, which is done based on the extraction of the features in the processes. So the training images were selected and the labeling of the cracks were employed. After that, the features were extracted from the regions. Labeling refers to the identification of cracks and non-cracked pixels in different representations. After that, the features were obtained and they were saved. While in the testing process, the test images were obtained. The test images were divided into several patches. After the separation of the patches, the features were extracted from the patches. Here the features refers to the mean and the standard deviations of the process patches obtained. So we calculate the features and the extracted features were saved. The features were then normalized. The normalized features and the training images features were then used for clustering. So the combination of these two features produces the clustered result. In the clustered result, based on the identified regions, the outliers were detected. The outliers were detected by the specification of particular ranges for the each regions. So if the patches were detected as outliers, they were eliminated. Otherwise, they were considered as crack. The elimination means they were all represented in black pixels, and if they are detected as cracks means they were all represented in white pixels. The identified cracks were then further classified into longitudinal crack, miscellaneous crack, and transversal crack. So this classification is done based on the comparison of different different regions in that are detected in the outliers, and based on that the cracks were classified as these. Finally, the process is overall performances were measured in terms of the accuracy of the process. Let me see the running procedure of the process. Select the file main.m which is present in the source code folder in order to run the process. Right click it and click on run file. You will get the process started. So first select the crack images that is given in the dataset. So for this process, for each images, the threshold ranges and the training processes has to be done separately, and hence we have provided the process for this single images alone. Hence the process will be exact for this image alone. So the image is selected, the input image is displayed here, then the image is enhanced and the distances were calculated, the clusters were obtained, and finally the cracks were classified. So first this is the input image and this is the enhanced image that we have got. The enhanced image is obtained by overall histogram equalization of the process, and then the datas were clustered, the features extracted were clustered based on the GMM clustering models, and we have analyzed the GMM clustering model values in the graphic. After GMM clustering, the road cracks were identified like this. The detected regions were calculated, and after that the detected cracks were extracted. These regions were superimposed on the original image and the detected crack regions were extracted, and after that the overall contours were extracted in the detected regions. This is the final thresholded image for the identification of the crack. The identified crack width and the WCS values were calculated in our process. From the thresholded image, the other regions were removed, and this is the final skeleton image calculated. And this is the removal of the small intermediate cracks available. And finally, the crack is classified as longitudinal crack. Thus, we have detected the crack in the road images, and also we have classified the crack based on the regions of the detected crack in the road images. Thank you.